In this video we are going to look at product and power rule for exponents, and we're going to develop these rules and see if we can understand why they are the way they are, and then we'll do some problems, some practice problems. Alright, so let's start with reviewing what an exponent is. So let's say we've got something like 2 to the third power, right? The base is 2 and the exponent is 3. So hopefully we all remember that that means 2 times 2 times 2, and of course that would be 8. Alright, well, what if we have, say, 2 to the third power, and we want to multiply that by 2 to the fourth power? Maybe there's a shortcut way we could do this. Well, like we just wrote, 2 to the third power is 2 times 2 times 2. And actually, let me do this one in a different color. Let's do 2 to the fourth power in red. 2 to the fourth power would be 2 times 2 times 2 times 2. And if we wanted to multiply these together, we would basically end up multiplying 2 by itself 7 times. Well, what is 2 times itself 7 times? It is 2 to the 7th power. Alright, so can we see a little shortcut we could use here? If we have 2 to the third times 2 to the fourth, we could add the 3 and the 4 and come up with 2 to the 7th. Now at first this might seem a little counterintuitive because we're multiplying these together, and yet when we multiply these together we're adding the exponents, but that is exactly what we need to do. Okay, and we can do it with variables as well. If we had, say, x to the second power times x to the sixth power, and we wanted to multiply those together, it would be x to the 2 plus 6th power, or x to the 8th power. And if you're not convinced of that yet, you could actually write the whole thing out. X to the second power is x times x. X to the 6th power is 6 of these x's multiplied together. 5, 6. And if we multiply both of those together, we're going to end up with x times itself 8 times. So it's x to the 8th power. It is not x to the 12th power. Alright, we do not multiply these exponents together when we're multiplying something with a common base. Now that's really important. It needs to be a common base, okay? If we had something like, when I say common base, I mean like this is a 2 and this is a 2. That's the base. Those have to be the same. This is an x and this is an x. Those have to be the same. If I had something like 3 to the second power times 2 to the second power, I can't really combine those together in any way. I could figure out the answer, all right? But it's not like 6 to the 4th power or something. To show you that, we could write it out. It's 3 times 3 times 2 times 2. Okay, and so I can't really combine these together. It's still just 3 squared times 2 squared, or 9 times 4, it would be 36, which is certainly not 6 to the 4th power. All right, so these numbers have to be the same if you want to add these exponents together. So our first rule, and I'm going to make a spot over here because we're going to go through about 3 rules here at least for us to write down our rules. If we want to generalize this rule that we just were working with, we could say x to the a times x to the b equals, oh, don't want that, x to the a plus b. A plus b. Okay, that's our first rule. I showed down here how the bases have to be the same if we were using constants like 3 and 2. That's the same thing if we had variables. So if we had x to the third times y to the fourth, all right, you can't simplify that any further. It's just x to the third, y to the fourth. Where if you had x to the third times x to the fourth, then that would be x to the 7th, all right, because this base is the same. Then we can add those together. A little variation on this. Let's get rid of this and do a couple more examples of this kind of rule. A little variation would be if you had something like 3x to the fourth times 6x to the second. Okay? So what we have here is basically one big term. There's no pluses or minuses in here. It's just a whole bunch of stuff multiplied together. If I really wanted to think what all this means, it means 3 times x to the fourth, which means all this, times 6 times x squared, which means all that. Now, you don't have to write all this out to get the correct answer, and we'll show how to do it very quickly. But I want you to understand what is meant by 3x to the fourth times 6x squared. It's just a whole bunch of stuff multiplied together. And remember, when you're multiplying, you have the commutative property. You can switch the order. So I could put the 6 up by the 3. 1, 2, 3, 4, 5, 6. And basically I end up with 3 times 6, which is 18. And these x's multiplied together, it looks like I have 6 of them. 1, 2, 3, 4, 5, 6. So the shortcut way to write that would be 18x to the sixth. Well, you can see you could get that answer without writing all this out by multiplying the coefficients. 3 times 6 is 18. And then x to the fourth times x to the second is x to the 4 plus 2. You have to add those exponents. That's what our rule says over here. And so that gives you 18x to the sixth. All right, so you can use this rule in conjunction with other multiplication if you had coefficients in there like 3 and 6. And when I say coefficients, I mean these numbers right here that are multiplied by the variable. These are the coefficients, so those get multiplied together. Whereas the exponents, since they're exponents on the same base of x, they get added together. All right, so that's our first rule. And that rule is called the product rule, okay, because we're multiplying. Product means to multiply. So what do we do when we're multiplying something with exponents? And that's our first rule right there. Let's look at another situation. So this one's called the power rule. And in this scenario, we have a base, say like x, to a power. Let's say the third, and then we're going to take that whole thing and raise it to another power, say the fourth. Okay, so we've got a power to a power. This is the power rule. Well, to figure out what's happening here, let's go ahead and write this out. All right, what does x to the third to the fourth mean? It means x to the third times x to the third times x to the third times x to the third. Right? This is x to the third to the fourth power. It means x to the third multiplied by itself 4 times. All right, let's take it one step further. What does x to the third mean? It means x times x times x. And this x to the third is x times x times x. And we'll just continue this process. All right, we're going to multiply all those together. Well, how many x's are we multiplying together here? We're multiplying x by itself 12 times. Which means x to the 12th power. All right, can we see a shortcut we could take up here, x to the third to the fourth? I hope you do. We could have got x to the 12th a little faster by just multiplying those together, right? That would have given us x to the 12th, and that is the power rule. So generally, we could say if we have x to a power, and we raise that to another power, we end up with x to the product of those two powers, a times b. That's the power rule. Let's try another one. Let's say we had something like, we could, the base doesn't have to be x. It could be some constant. Say we had 3 to the fifth to the second. Well, we could punch that into our calculator, 3 to the fifth and then square it. But we could make it a little easier on ourselves by simplifying this. 3 to the fifth squared. We're going to use the power rule because we have 3 to a power, so we're going to multiply the 2 times the 5, and we're going to end up with 10, right? 3 to the 10th. And you could punch that in, oops, wrong color. Let's see if we can get these to match. Is that the right color? we could multiply this out on our calculator. Let's see, I can't do this one in my head. I have a calculator handy. Let's verify that this is true. So 3 to the 5th power, if I did it this way, all right, 3 to the 5th power is 243. And then if I squared that, I end up with, this comes out to be 59,049. All right, if I punch in 3 to the 10th on my calculator, 3 to the 10th power, you end up with the same thing. All right, 3 to the 10th is 59,049. Those are kind of big numbers, so I mean you could punch it in on your calculator and see that that's true. Maybe we should show one of those with some smaller numbers that you could do in your head. Let's say we had, this is a good one, let's say we had 2 to the 3rd squared. Okay, so if I just did that out without using my rules, without using any rules, I would do what's in the parentheses first. So 2 to the 3rd is 8. And then if I square that, I get 64. All right, if I use my rule and I multiply these together, I end up with 2 to the 6th power. All right, 2 times 2, and you could punch this into your calculator, but let's just do it in our head. All right, so 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So you end up with 64. Okay, so that works the same way. Now, if you have a variable, like over here when we had, oopsie, x to the 3rd to the 4th, you know, you can't actually figure out the answer because you don't know what the value of x is. So you're kind of forced to simplify it. Whereas if you have a base, you could, you know, simplify what's in the parentheses first, or you could use the rule. But either way, you're going to come up with the same answer. Okay, let's see here. Let's do, let's get rid of this. Let's do one more rule, and then we'll practice some problems. Let's see. Let's say we have a fraction like x over y, and we're going to take that to the 3rd power. Okay, so this rule is a little more intuitive, I think. If you have x over y to the 3rd power, that means x over y times x over y times x over y. And when you're multiplying fractions, you multiply straight across, right? So x times x times x is your numerator. That's x to the 3rd. And y times y times y is your denominator, which is y to the 3rd. So basically, when you have a fraction to a power, you need to apply that power to both the numerator and the denominator. You need to take both the numerator and the denominator to that power. Let's put some numbers in there. Look at another example. Say we had 2 over x to the 4th. Okay, so what we need to do is we need to take 2 to the 4th power and x to the 4th power. So 2 to the 4th power would be 2 times 2 times 2 times 2. What's that, 16? I think that's 16. And then in the denominator, we would end up with x to the 4th power. So this 3rd rule says if you have a numerator and a denominator, all right, an entire fraction to a power, you need to make sure to take the numerator to that power and the denominator to that power. Okay, so let's do a couple problems where we have to use these rules, and some problems you actually end up having to use all the rules in the same problem. They can get a little complicated, so it's really important to have these rules memorized or be able to derive them, be very comfortable with them. All right, let's see. What could we do here? Let's do 2x to the 5th, and then let's take that whole thing and take it to the 3rd power. All right, so if I have these two things in parentheses here, and I'm going to take that to the 3rd power, that means I have to multiply 2x to the 5th times itself 3 times, right? Okay, so I have to do 2 times 2 times 2. Remember, I can change the order here, and you don't have to write all this out, but I like to write it out to show what I'm thinking. If I do 2 times 2 times 2, that's 8. And x to the 5th times x to the 5th times x to the 5th would be x to the 15th. Remember, because we add these exponents here, 5 plus 5 plus 5, using this first rule. I'll call this rule number 1, using rule number 1. Rule number 2, rule number 3. Now, what would be a shortcut to that? Okay, how did we get 8? We took 2 times 2 times 2. So everything in this parenthesis has to get taken to the third power. So I have to take the 2 to the third power, and I have to take the x to the 5th to the third power. 2 to the third power is 8, and x to the 5th to the third, I could have used a shortcut and used rule number 2 and just multiplied the 5 times the 3 and not gone through writing all this out. Okay, and go directly to the answer. Let's try another one of those and use a shortcut. Let's put a negative in there. This will be exciting. Negative 3y to the 10th squared. Okay, what would that be? Well, we have to do negative 3 squared. So negative 3 times negative 3 is positive 9. And y to the 10th squared, we have to use rule number 2 because we're taking a power to a power. So we have to multiply 10 times 2, and that is 20. So there's our answer. All right, we could actually add another rule here that we're kind of using. If you have two things in a parenthesis to some power, like here we had the negative 3 that's squared and the y to the 10th that's squared, you have to take both of those things to that power. And that's an a, that's not a 9, that's an a, okay? All right, let's try a couple more. Really, the key with these is just doing a lot of examples and looking at a lot of examples. Okay, I'm going to do a more complicated one here. All right, let's do 3x to the 10th times 6x squared to the third. Okay, so we have a lot going on here. And we always need to remember our order of operations. We're going to use our order of operations as well to know what to do first, right? So I have this thing multiplied, 3x to the 10th multiplied by 6x squared, but I have to take 6x squared to the third power. So by the order of operations, I have to do the exponents first, the powers first. So the first thing I'm going to do is figure out what is 6x squared to the third. And then when I get that answer, I'll multiply it by 3x to the 10th. So I'm just going to bring this 3x to the 10th down. All right, what is 6x squared to the third power? So this whole thing is to the third. So I have to take 6 to the third power. I think that's 216. 6 times 6 times 6? Yeah, 216. All right, and I have to take x to the second to the third power. So which rule am I going to use for that? Hopefully you said rule number 2. X to the second to the third is a power to a power, so I have to multiply the 2 times the 3, and that gives me x to the 6th. All right, so really when we went from here to here, we used rule number 4 because we took both things in that parenthesis to a power, and we used rule number 2 because we multiplied the 2 times the 3. So we used 2 rules on that step. All right, so now we have to multiply these two things together. And remember, we could write this all out. It's just all multiplication. We can change the order. So we can think of this as 3 times 216 times x to the 10th times x to the 6th. That's really what's happening here. We could change the order because it's the commutative property. These parentheses just mean multiplication. The 3 next to the x to the 10th means multiplication. So you could write it out like that and switch the order by the commutative property. So if we multiply these together, what do we get? 648. All right, and what is x to the 10th times x to the 6th? Well, that's rule number 1. So we're going to add these exponents together, and we're going to get x to the 10 plus 6, which is 16. So getting from there to there, we used rule number 1. And this is it, right? We can't simplify this any further. That would be our answer. All right, so some problems you have to use more than one rule in order to simplify the problem. But always ask yourself, what rule am I using to simplify this? And because that's, as long as you're looking at these rules to justify your steps, it's really going to help avoid mistakes. one last thing I want to bring up is thinking about this compared to combining like terms. So say you had something like 3x to the fourth plus 6x to the fourth, okay? The big difference in this problem compared to what we've been doing is this plus right here. So when you have a plus sign and you're combining like terms, remember you're verifying that this variable and exponent part is the same, and when you add those together, you're simply adding the coefficients, and then you're keeping that variable and exponent part to the same. It's like 9 cows plus 6 cows, or excuse me, 3 cows plus 6 cows is 9 cows. All right, 3x to the fourth plus 6x to the fourth is 9x to the fourth. Whereas if we were doing 3x to the fourth times 6x to the fourth, all right, see the difference? Here we're adding, here we're multiplying. Now we would need to multiply the 3 times the 6 and get 18. And x to the fourth times x to the fourth, we're going to use rule number 1. All right, x to the fourth times x to the fourth is x to the 4 plus 4, or x to the 8th. All right, that's a big difference there. So really pay attention to whether you're multiplying terms or adding like terms together. It makes a difference. Similarly, if the exponents are different, remember you can't add like terms. So if you had something like 3x to the 6th plus 6x to the 4th, and your direction said simplify, you'd be like, great, because I can't simplify that. I don't have any work to do. You cannot add those terms together because they are not like terms. In order to add terms together, this part needs to be exactly the same. Whereas if I had 3x to the 6th times 6x to the 4th, knock yourself out. You can multiply these together. It's 18x to the 10th. Okay, so when you're multiplying, you can use rule number 1. It doesn't matter if the exponents are different. You're going to add them together. When you're adding like terms, it does make a big difference, right? To combine like terms, that exponent and base needs to be exactly the same.